So today we're going to simplify the following rational expressions and state any restrictions. Here's the three we're going to do today. All right, so first let's talk about how would we simplify something like this? Well, what we're first going to do is factor it, because if these two quadratics have any of the same factors, we can cancel out those factors. So I'm going to start by factoring the top. So quick reminder, how do we factor a quadratic? Well, we need to find two numbers that multiply to the c value, which in the case of the numerator here, it's 2, and that add to 3. So those numbers would be 1 and 2. So this multiplies, or this factors to x plus 1 times x plus 2. And if you're ever not sure whether or not you factored correct, make sure to expand and see that you do get the original expanded form back to you. Then for the second one, we have x squared plus x minus 2. So how do we factor this? Well, what are two numbers that multiply to negative 2, which is this number here, and add to 1, which is the invisible coefficient here for the x? Well, two things that multiply to negative 2 would have to be negative 1 and positive 2, or negative 2 and positive 1. In this case, we want the first one. We want negative 1 times positive 2, because negative 1 times positive 2 is equal to negative 2, and negative 1 plus positive 2 is 1, right? So therefore, the answer is going to be x plus 1, or sorry, x minus 1 rather, x minus 1 times x plus 2, like that. Okay, and now we're going to cancel out the x minus 2's and get that the final answer is x plus 1 over x minus 1. And that's the simplest form we can get. We can't factor either the numerator or denominator any further or cancel anything else out. The other part of the question was to state any restrictions. So a restriction occurs whenever we have something, a value for x that would make the function undefined. Now, in the context of rational equations, that means the denominator cannot be 0. And so any value that would make the denominator 0 is a restriction. So the first restriction is that x cannot equal to 1, because notice that if x was equal to 1, and we plug that in here, we would get 2 over 0, and 2 over 0 is undefined, right? Because 0 is in the denominator there. Now, what about this part here? Over here, we used to have an x plus 2 in the denominator. However, we canceled it out. So even though we did cancel out the x plus 2, we're looking at restrictions on the original function, on the original equation over here, not on just the final answer. And so we also would need to include that x cannot equal to negative 2. Right, now that said, I do understand that if we were to plug in x equals minus 2 to the final answer, we'd be fine. We would get that that's defined somewhere. However, if we plugged it back into the original or into the second step here before we canceled out, we would end up getting a 0 in our denominator, and we can't have that, right? And so anything that was ever a denominator, ever at any point, must be considered for restrictions. So the restrictions are that x cannot equal 1 and x cannot equal negative 2. However, assuming x equals something other than those two values, this is our final answer. Okay, let's move on to B. Okay, so for B, first thing I'm going to do here is I am going to factor. So let's start with x cubed minus 27. So recall the difference of cubes formula. Recall that for difference of cubes, that a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared, like that. So if we apply that to our denominator, we will end up getting x plus 2 in the numerator still. And then in our denominator, we're going to get a minus b, which in this case, we know that a is equal to x and b is equal to 3, right? And we can find those by taking the cube root of x cubed, which is x, and then the cube root of 27 is 3. So that's how we got a and b, by taking the cube root. Since originally in the equation we have a cubed minus b cubed, and here we have two different cubes. So therefore, x minus 3 times x squared plus ab, which is 3x, plus b squared, which is 9, and then that's times this part here, x squared plus 3x plus 9. And then in our next step, as you can probably imagine, these two cancel out, and we are left with x plus 2 over x minus 3, like that. Okay. Now, that being said, what are the restrictions here? Because here's the final answer. So what are our restrictions? Well, of course, x cannot equal to 3, because if x equals to 3, then our denominator in our final answer would be 0. The other thing that was once in the denominator was the quadratic x squared plus 3x plus 9. However, that is not going to actually give us any additional zeros, and so therefore there's no other values for which the denominator could be 0. And to prove it, let's find the discriminant of this quadratic of x squared plus 3x plus 9, and assuming that it is less than 0, that means that there are no solutions to the equation x squared plus 3x plus 9 is equal to 0, meaning that there's no other values in this overall equation that we can use. So if we do b squared minus 4ac, that's going to be 3 squared minus 4 times 1 times 9, which is equal to 9 minus 36, which is clearly less than 0. And therefore, that means that, this equation here, this has no real solutions. Therefore, we're good to go with just x cannot equal to 3. Okay, let's do this next one here, part C. So first step, I'm going to factor both the numerator and denominator separately. So for the numerator, all we can really do is just common factor out the 2. For the denominator, we can use the difference of squares formula. So recall that the difference of squares formula is that x squared minus y squared is equal to x minus y times x plus y. So in this case, we have x squared minus 4, meaning our version of x is just x itself, actually. And our version of y is going to be 2, because the square root of 4 would be 2. So therefore, this is equal to x minus 2 times x plus 2. Then I'm going to cancel out the x minus 2's, and my final answer is 2 over x plus 2. So that's my final answer. What are my restrictions? Well, x cannot equal to negative 2 for one thing. Otherwise, our final answer would indeed have 0 in the denominator. But also, x cannot equal to positive 2 either. Because in this step here, even though we did cancel it out, at one point x minus 2 was one of the factors of our denominator, and so therefore x cannot equal 2. Because back in the original equation here, if we plugged in either 2 or negative 2 into our original, we would get 0 in the denominator, and we can't have 0 in any denominator ever and still have the equation be defined. All right, well, that is all for this one. Feel free to leave any questions you have in the comments section, and we'll see you for the next one.